Okay, ladies and gentlemen, we've already talked about what it means to be directly proportional. Now, remember we said a proportion is a comparison of two ratios. And we can write a ratio as a fraction. Now, if two variables are directly proportional, their ratio will always be a constant. So our definition of directly proportional was that if you take one variable and you divide it by another, you get a constant. To help you visualize this relationship, we rearranged to make it an equation of y as a function of x. So we just multiplied the x over. And we talked about that you should recognize this equation as a straight line. Y equals mx plus b. So here the constant k is the slope and the y-intercept is 0. Now that k could be positive or negative. So it could have a positive slope or a negative slope. When one variable goes up, the other could go up, or when one variable goes up, the other goes down. The key thing is that they always have the same ratio. I now want to talk about what it means to be inversely proportional. And before, we're going to quit using that term for just a second, because to help you understand it, I want to relate it back to our direct proportion. Not all variables are directly proportional. It turns out that they can be proportional in terms of other things. So sometimes one variable is directly proportional to the inverse of another. So let's say that I wanted to look at that, and let's say I said that y is directly proportional to the inverse of x. Now remember, the inverse of x is its reciprocal 1 over x. So if y is directly proportional to the inverse of x, then y divided by 1 over x will be a constant. Well, we can do just a little bit of arithmetic to simplify this. If you divide by a fraction, you multiply by its reciprocal. So if we do y times x over 1, this really simplifies to just be y times x is a constant. And this is usually the definition that we give for something being inversely proportional. Now, to help you visualize that again, we're going to rearrange this to write it as y as a function of x. In other words, we're going to solve for y. To do that, I'm going to divide both sides by x, so I can say y equals k over x. Now, you may not immediately recognize this, but you should have learned about this in your math class. It's the reciprocal function, and when we graph it, we call its graph a hyperbola. Even if you don't know that right off the bat, you should be able to recognize some things about this. When this x variable gets really big, we're dividing a constant by a really big number. The bigger number we divide by, the smaller the answer gets, and it gets closer and closer to 0. So when we divide by a huge number, we're going to get an answer that's really close to 0. In other words, as x gets bigger, y gets closer and closer to 0. We have a horizontal asymptote at y equals 0. Another thing that you should recognize is that you can't divide by 0, but you can divide by things close to 0, things that are really small. And when you divide by something really small, you'll get a really big answer. So as x gets closer and closer to 0, y gets bigger and bigger and bigger. We have a vertical asymptote. If we were looking at negative values, we would have another part of the graph over here. Usually in chemistry class, we're not going to be dealing with negative values, so we're just going to look at that part of the hyperbola. So in summary, if things are directly proportional, their ratio is a constant and their graph is a straight line. If things are inversely proportional, their product is a constant and their graph is a hyperbola.